as part of this training now. Yeah. So this is the architecture that we follow, or that will be followed by Informatica data quality. Yeah. So if you look at here, where we have three broader layers, namely what you call Informatica, where namely client, server, meta, and content layer. I repeat, client layer, server layer, meta layer, and content layer. These are the four layers of what we have in the data quality architecture, or Informatica architecture also you can say. Yeah? So which means all the components that we have within the Informatica product suite, right, which I was trying to talk. Yeah, all these components, right, all of them would follow similar architecture. So data quality also will be in line with the same architecture. Yeah? But in this diagram, you could see only data quality specific clients, data quality specific services, data quality specific content. Yeah? Now, let us talk about in the client layer, we have two broader clients, namely Informatica Analyst and Informatica Developer. I repeat, we have two clients in the client layer, namely Informatica Analyst and Informatica Developer. Yeah? So Informatica Analyst client is a web-based client which will be used to carry out analysis by using web-based client, which we call Informatica Analyst client. I repeat, Informatica Analyst is a web-based client which will be used in order to carry out what I call analysis. Yeah? And we also have another client which we call Informatica Developer, which I was trying to show some time ago, which will be used what I call in order to carry out data quality activities. Yeah. So IDQ is a combination of both. Sandeep, you want to ask a question? Let me unmute. Yes, Sandeep. Go ahead, Sandeep.
Yeah, no, my question I just typed, like IDQ comes under Informatica Developer?
IDQ is a combination of analyst and what you call development part, both.
Oh, okay.
IDQ is a combination of both, but pre 9.x, right, which is this is 9.1 or 9 architecture, right? If we talk about pre 9.x architecture, this is 8.6.2. In this case, we have two clients. IDQ is separate, different from IDE, which is Data Explorer. So in this case, you are right. So IDQ is a separate client which we use. Yeah? But from 9.x onwards, IDQ means what? Both. Which means both means what? Analyst as well as developer. Put together is what we call data quality or IDQ. Sandeep? Yeah. Any other questions? Fine.
No, I'm fine. Please go ahead.
Yeah. Now, the next is what we can get into server layer, yeah, where we have different data quality services. I'll talk about that in detailed architecture. For now, just remember that there are different data quality services, and if you think from the notational semantics perspective, we have data quality server. Under that, we have different data quality services. What are those? I'll talk about them with the detailed architecture. This is a very high level architecture. Now, so what do we do as part of services? To solve the request of what is being sent from either analyst client or from developer client. I repeat, all the services which comes under data quality server will be used in order to service the request of what is being sent from analyst and developer. Now, the next is what? Meta layer, which is what? A repository. I repeat, third layer is going to be what? Meta layer, which we can also call that as a repository layer, where we are going to store metadata that is required in order to perform all data quality activities. I repeat, we use what we call repository layer in order to carry out all the data quality activities, which means there is a metadata which will be stored in the what we call database or whatever. All the metadata elements or some of the metadata elements will be used in order to take care of analyst operations and developer operations. I'll talk about them. What are those metadata things that we need to take care while what we call building any data quality activities. Yeah. Now the next is what we have another layer which we call content layer. Can you see here? Which we call reference data in terms of address reference data or identity reference data. I think Ramakrishna was trying to ask one question, what is meant by identity, what is the resolution or whatever. Yeah? So which means in case if you want to perform matching for different business data driven elements which we call identities, like we have address, contact, wide contact, household and so on. In case if we have these many identities, what we need to have the corresponding reference data which need to be stored in a file system is what we call reference data. I repeat, there is a reference data belongs to each of these identities. For example, address reference data. So the way we represent address in what we call in India would be different from other countries. Siva? Now let us say we have got the reference data for India country. Now what do we need to do? We need to know like how to compare source system address data against with the reference data of what we have for India country. This reference data we are going to get it from Informatica. So what do? We are going to compare the source system address data against with address reference data for India country and see whether the address data what we got from source system is right or wrong. Yeah? So that will be done by using what? Address doctor engine. Yeah? So address doctor is a validator which is going to validate the source system address data that we get from through developer and compare that with what we call reference data and see whether the address can be delivered or not. That will be done by using what? Address doctor engine. Yeah? In simple terms, verification. We do source data, address data against with the reference data. If it is verified, address can be delivered. If not, address cannot be delivered. We can see the reasons why the address cannot be delivered. I'll talk about that with practical examples when we talk about address validation that we have in data quality. Yeah? Now, we also have reference data for identities which I was trying to talk. Let us say household or contact or wide contact and so on, or person. So assuming that there is a person reference data that we got it from Informatica for India country. Yeah. So now we need to install this reference data in the file system for person. Now what do we get? We are going to get person data from the source system and there is a identity match transformation within the data quality which we are going to use to compare source system person information against with what we call reference data for person and see whether we have any matching records or not. Based on that, we can start generation of good data for this particular identity. Which means what? First we need to obtain a license for person identity from the Informatica company belongs to respective country. Remember, for each country, reference data would be different because the way we represent data in India country would be different from other countries like the US, China and so on. So, if your project need support for multiple countries, let's say 3 or 4 countries, so we need to buy license for what you call all of those countries independently, or bulk also we have it. It depends on the license. Yeah? So we need to buy license anyway for all the countries. Once you do that, you get a reference data. Once you get reference data, you need to install it. That part I'll explain that. Then start performing identity matching, which means we'll identify do we have any duplicate records associated to this particular person. Yeah? So that's what we do as part of identity matching. Yeah? But anyway, I will elaborate that when we talk about matching layer in the data quality. Yeah? So broadly there are 4 layers: client, server, meta and content layer. Just remember this. These are the highlights. Yeah? Now let me elaborate with bit more details. Yeah? So when you send a request from unlist client, what happens is this particular request would be sent to particular data quality server, yeah, which in turn is going to look for do I have corresponding underlying services through which I can obtain repository information. Answer should be yes. Yeah? So which means data quality server is going to talk to repository and get the metadata information in order to service this particular request. Once you get it, then it is going to look for specific service, let us say profiling. Then it is going to look for profiling service, and if we have it, it means the corresponding service is up and running. It is going to service and you will get a response back to analyst where you could able to see the result or status of that particular request. That is what will happen with this particular request. Clear? Similarly, we can send n number of requests. That's a one request that we are going to send it from the Informatica developer. Then what will happen? It is going to talk to what you call repository in order to send or understand the request, then pass it over to the corresponding server or services which will be used to respond to that particular service. Then you will get a response back to the developer where we could able to see the status of that particular request. Yeah? So this is what happens with respect to what we call very high level information about this particular architecture. Now, if you look at what we call high level bullet points, there is going to be a central repository which we call model repository. Remember, the repository of what we use for data quality would be different from other tools of what we have in Informatica product suite. Yeah? I repeat, the repository of what we use for these two tools would be different from for this and for this. Which means what? Repository is different. For example, the repository that we use in Power Center is what? Power Center repository, which is through Power Center repository service. But in data quality, where we use model repository, which is what? Through model repository service. So MRS means what? Model repository service. Yeah. So total repository is totally different for both, which is simple. Power Center and data quality repository is different. Now let me try to open what I call other law. Oh, I don't have that. Yeah, if you look at this detailed architecture, this you guys would have seen earlier, where we can see detailed services of what we have in the data quality. Yeah, this is just an expansion to the previous high-level architecture. Let me explain that. Here we have Informatica Analyst client, first one. Second client is what? Informatica Developer. And corresponding services are Model Repository Service. Can you see here? Data Integration Service, Analyst Service, Content Management Service. I repeat, the major services are the services that we use within the data quality are as follows: Model Repository Service, Data Integration Service, Analyst Service, and Content Management Service. Yeah? These are the what I call services that we need to create by getting into the admin console. Yeah? Now, I'll just describe what each service does. Model Repository Service will be used in order to take care of repository activities. It is what? Creation of repository elements, like creation of metadata, like creation of metadata tables, or structures, or indexes, or synonyms, or sequences, or packages, or SPs, or any other database objects. All of them will be taken care as part of Model Repository Service creation. Plus, we also create a content associated to each metadata element. For example, table. What is the basic minimal content that we need in order to perform any data quality operation? So that also will be part of what we call Model Repository Service creation. In simple terms, metadata plus content is equal to, or both will be taken care as part of Model Repository Service creation. Clear? Now we have repository ready. Now what do we do with that repository? We read the data by using repository elements. Once you read it, we need to move it, right, from one task to another task, or from one transformation to other transformation. Which means what? If we read the data from a file, we need to apply some business logic, right? To do that, we need to move this data from one to another where we can apply business logic. Who does that? Data Integration Service. So, Data Integration Service will be used in order to move the data from one transformation to other transformation. I repeat, Data Integration Service will be used in order to move the data from one transformation to other transformation. Clear? Similarly, in Power Center, we have separate integration service which we call Power Center Integration Service, which will be used in order to move the data from one task to another task. Remember, yeah? Which means what? The integration service of what we use in data quality would be different from the integration service of what we use in the Power Center. Yeah? Clear, right? So that's what we do as part of this. Now, the next is what we have. The Analyst Service, which is going to be the third service. I repeat, third service is going to be what? Analyst Service, which will be used in order to take care of what? To perform web-based analysis or web-based auditing, web-based fixing of bad records, and so on. In simple terms, in order to bring up Informatica Analyst client, we have to have this particular analyst service which should be up and running. So without this service up and running, we can't bring up Informatica Analyst client. Yeah, remember. So analyst service is mandatory, or it should be up and running always, so that we can log on to web-based client, which we call Informatica Analyst client. Within that, what are the features of what we have within the Informatica Analyst kind, that I am going to elaborate that in detail with practical examples once we start Informatica Analyst tool. Yeah. These are the what I call 3 mandatory services in order to what I call take care of analyst operations and data quality operations. These 3 services should be up and running always. Remember, yeah? That's why I said all these 3 services are mandatory services. What are those? Model repository service, data integration service, and analyst service. These are the mandatory services. Yeah. And once we understand that, there is one more service which we call content management service, where I am trying to place the cursor, which will be used in order to deal with the content with respect to what address content or any other identity content, which means in order to deploy the content corresponding to each country, let's say India, US and other countries, we need to have this content management service which should be up and running. Once we have it, we can deploy the content associated with any country into the file system, which we call reference data for the respective population. Population means here the respective country. Just remember that. Yeah? So these are the what I call services of what we are going to create as part of this data quality. I'll show that anyway. We need to install this data quality, right? So as part of that, I'll show step by step how to create them from a scratch, so that you will understand from a scratch, from admin perspective. Yeah? Installation and configuration part also will be covered as part of this training. I've just talked about theory part so far. Yeah? Now, analyst and Informatica developer will make use of all these services. Yeah? Now, there is a repository, as I said earlier, which is a model repository, which is required in order to take care of all data quality activities using this particular repository. Yeah? So without repository, we cannot do anything in the data quality. So first and foremost thing is what? Make sure that we have what I call a repository which is created before we get into the creation of any other services, yeah? Which is mandatory. And remember, both the clients which we call Informatica Analyst and Informatica Developer, both will make use of a single or central repository which we call model repository. I repeat, both the clients, namely Analyst and Developer, will make use of central repository which we call model repository. If you look at this line, Informatica Developer connected to model repository, Analyst has been connected to model repository. That is why it is called central repository, which means what? Any change that you do with respect from Informatica Developer will be visible in Informatica Analyst and vice versa. Meaning what? Any change that you do in or any metadata change that you do in Analyst will be visible in Informatica Developer because of what? Central repository, which we call model repository. Clear? This is with respect to what we call the specific services of what we have within the data quality. All of those services, if you think from the notational semantics perspective, all of them would come under the category of data quality server. Yeah? So that's what we have with respect to data quality services. Yeah? So which means what? This is going to be the model repository, is going to be the central repository which can be shared by all the users and which can be shared by both the tools, which is what? Analyst and developer tool. We have just seen the diagram where we could see what we call the connectivity of repository with analyst and developer. Clear? Now, the next is what? There was a dictionary concept in pre 9.x. Yeah. Before I talk about that bullet point, if you have any questions, please shoot out now so that we can discuss. Yeah? Because this architecture we need to understand very clearly before we get into the hands-on sessions. Because this architecture you should always need to have back of your mind so that you can always correlate like what are you doing, where are we. Yet once at that, this particular architecture should be what you call that back of your mind. Yeah. Any questions from Arjun, Chandra, Gauri, Jyoti, Karthik, Krishna, Kumar, Rahul, Krishna, Sandeep, Sivas, and Vidya? Any questions from anybody? No questions? You guys are there, right? I think. So there is no voice problem, I guess. Yeah? You guys could able to hear me, right?
Yes, yes.
Okay, Kumar. Okay. Fine. Now, let us talk about, you can speak out anyway because you can unmute and speak out because now I have unmuted all of you. Now, we'll talk about reference data. Remember, in order to perform any standardization, meaning what? Let us say we have a street which can be represented in many ways. ST, ST dot, STR, STR double ET, STR, R, and so on. There are different ways to represent the same data. This is an example of what we call street. Yeah? Similarly, we can think of international, INT and INTL dot and international and inter and so on. Which means what? International can be represented in many ways. So as part of this standardization is the term where we are going to standardize the source data, international to one unique representation, street to one unique representation, and so on. Which means what? How are we going to come up with what we call a unique representation of the source system data is what we call standardization. Yeah? Which means what? Convert n number of transpositions, misspellings, or probable representations with a single or unified representation of that data is what we call standardization. So standardization in simple terms, it is a simple find and replace, yeah, which is what we do as part of standardization. To do that, we use what we call a reference data. Can you see here? So which means what? There is a reference table manager within this unlist client that we are going to use in order to create the reference data from a scratch. So that reference data would include all these probable representations, all these misspellings, all these transpositions, yeah, ITN and so on. Yeah. Which means what? All of them need to be defined as part of unlist client using a reference table manager, which we call reference data, or in simple terms, user defined reference data will be taken care by using what? A reference table manager, IDE. Within IDE means what? Integrated development environment. Within what? Unlist client. Yeah. For what? For standardization. One of the example, we can also use reference data for even for parsing, even for labeling, even for other data quality activities. I'll talk about that where and all we are going to make use of this particular reference data in order to perform data quality activities. Yeah, clear, right? I just gave one example where there is a need to think of building user defined reference data so that we can start carrying out standardization within the data quality. Yeah. Now, when you talk about the model part, which means what data model, remember the data model of what we built in pre 9.x versions of data quality would be different from 9.x versions of data quality, which means what? This 9.1 architecture would be in compliance with the model of what we have in 9.x, which means what? 901 model will be adapted from 9.x versions, 9.1, 9.5, all that. Which means what? Till today, which is let's say 9.5.1, which is the latest version of data quality, where we still use what I call same model, which we call 901 model, which is in compliance with this particular architecture, which is web-based client, thick client, server, metadata or repository and content. That's what we have. Plus, we also have some more parts which I'll talk about that as part of model, like profile model, data model, or within that we have conceptual, logical, physical models. So all of them would be in line with 901 data model. Yeah? Now, which means what? Simple visual representation of data will be in compliance with 901 model. That's it, nothing else. Yeah? Now, the next is what we have. Connections. Remember, in order to get connected to n number of databases and start reading the data and apply data quality operations, right? While doing that, are we going to create connections in the central location, or are we going to create a connection which is specific to each mapping? Answer is the former one, which is central, centrally we are going to manage all the connections, which is not the case in case of previous data quality versions. Yeah? Which means what plan is just like a mapping where connection details will be embedded within that particular plan. Which means what? The scope and visibility of those connection details are bound to that particular plan. Which means what? Those connection details will not be available for other plan. It means other mapping, to make it very simple. Yeah? So that's one of the beauty part of 9.x architecture. So the complete architecture will be in line with SOA style, which is service oriented architecture. Because as we have seen in this particular diagram, where we have everything will be represented in terms of service. What are those? Like a model repository service, data integration service, and analyst service and content management service. That is why this data quality will follow service oriented architecture. Clear? That's what we have with respect to architecture explanation. Yeah. So from the next session, what we need to do is we need to start understanding how to install the data quality and how to perform different data quality activities. We'll start with analyst or developer, whichever you guys are going to like. Yeah. So it's better to start with developer, because you guys are going to play a primary role of developer, right? You can start with a developer, understand different developer activities like all development tasks, and once you understand that, then we can get into analyst part, which will be done by subject matter experts or business analysts or business users or IT managers. Yeah? That part would come after this first part should be that, but if you think from the development perspective, then we need to focus on what Informatica developer client. Yeah. Yeah. Now what we will do is address is 111 and street name and city and zip code and so on. Yeah? Similarly, you would have given the account details in what you call our personal details in another bank where you have not given address but you have given the name. Yeah? Now, assuming that we have this kind of data on both the banks, once we have it, after what you call merger, yeah, what happens? Which means what after merger, let's say bank 1 has been what you call acquired by bank 2 or vice versa. So which means what? You will have what you call two entries in the same bank. Yeah? In that case, what we need to do here is we need to start identifying what we call the duplicates. Yeah? Or do we have any matching records? In the sense, are these two records belongs to what we call same customer or not? Yeah? So that's where we need to start identifying the duplicates. Yeah? So how do you identify the duplicates? Yeah? So from these two records after merger, right? First of all, do we consider these two records what it called yeah, that's fine now, Sridhar. So I just started with when to go for data quality. You know, I was trying to give the example like whenever there is a merger or acquisition happens, right, from one bank with another bank or from one company with other company and so on. In such cases, there is a chance to have a duplicate data. Yeah? So we need to come up with what is called good data in case if we have this kind of duplicacy. To answer that, data quality tools are going to help us on solving this problem. What do? We do what? First, see whether these two records after merger are similar records. So that's where we need to identify whether they are matching records or not. To do that, this matching within this data quality would be expressed in two ways. One is what we call exact matching strategy. Other is what we call probable matching strategies. We have two types of matching strategies. One is exact, other is what we call probable. Yeah? So once we have this, the next step is going to be what? How are we going to what we call identify? In case of exact, assuming that we are going to make use of this name as a column in order to what I call identify matching records. Yeah? If you take a name column from bank 1 is not exactly similar to bank 2. So no duplicacy. Yeah? No dupes. Now the next is what? We need to apply or we need to do the same thing for probable also. This is what it called case 2, where we need to talk about probable matches. So which means what? ABC with ABC1, if you go with let's say 80% of match or 70% of match or 90% of match, whatever. So which means what? This percentage of match, I'll talk about it later. For now, what we could remember here is in case based on this percentage, yeah, in case if we have duplicates, then also we consider such records as what we call have got matches. Meaning what? We have ABC1. There are different algorithms where we can use or where we can use them to calculate percentage of match. I'll talk about them later. For now, assuming that as per the business, as long as you have 80% of match, consider such records as what we call duplicate records or similar records. So in this case, these two records will be considered as what? Duplicate records based on what? 80% of match. Yeah? Now we identified that these two records belongs to one single customer. Once we know that, next step is going to be what? We need to start creation of good data as a result of these two records, which we call master record. How are we going to create that? To do that, we have what we call consolidation or merge. Yeah? Consolidation, where we are going to convert n number of input records to a single record. In this particular example, n is equal to 2. This means 2 records will be converted to a single record, which is what we are going to do now. Yeah? Based on what? Different consolidation rules that we can define here. Yeah? So which means what? We can define different consolidation rules. As a result of that, we can start formation of a final record, which we call a master record. Yeah? Let us start building rule. For example, ABC1 is similar, right? First rule, let us say we have what? Whichever column has got longer in length, which means what? Let us say if you take full name as input column, where we expect what we call a name which has got more number of characters, right? That will be considered as what we call good data. Yeah. So for example, assuming that in this particular bank 1 you have given short name, in this bank 2 you have given the full name. Yeah. So in that case, we need to make this particular value to be survived rather than compared to this particular value. So how are we going to take care of that? To do that, we need to what we call use consolidation rule. First rule is going to be what? Whichever column or whichever record for this particular column, which is a name column, has got more number of characters, make that particular column value to be survived. In this case, out of these two records, ABC1 will be survived because ABC1 has got more number of characters than compared to what we call ABC, yeah? Which is what you can see. If you apply same concept even for what we call second column, then what will happen? This address, which is from first row, would get survived, which means what? One name column from second row, address column from what we call first row, which is from bank 1 and bank 2. So we are mixing what? We are trying to create a master record, which is a combination of data from multiple banks or multiple sources, which is what we call master record. Now I repeat, one column data from one record, other column data from other record. We are going to mix up what we call multiple records, yeah, output, and create what we call final record, which we call master record. So this will be the final record, a result of data quality. That is what we do in any data quality tool. Yeah? So we have several data quality tools, yeah? Like we have what we call IBM InfoSphere quality stage. Yeah? So we have IBM InfoSphere quality stage, Informatica data quality, and we have SAS Dataflex, yeah? And we have what we call Trillium, and we have what we call we have Address Doctor, and we have First Logic, and so on. So we have what we call different quality tools that we have in the market. Out of them, Informatica data quality, which is IDQ, is a number one quality tool because of what we call the kind of features of what we have in the IDQ, plus we also have extra capabilities with respect to what you call taking care of multiple countries which we don't have it with other quality tools. Yeah? So that is why this IDQ is leading the market in comparison with other quality tools. Yeah? Now, previously there's a question from Narek. Is it address doctor is not part of IDQ? Now answer is yes, not what you call 3 years back, because address doctor is a separate tool altogether which will be used for address verification. Now Informatica acquired that. After that, now address doctor is part of what you call data quality. Yeah? So now it is a part of data quality, not before. Yeah? So that is why I listed that as a separate what you call tool. Naresh? So that's it. This is what we do as part of what I call data quality. Now we know why data quality. Now the problem with the existing life cycle is what? If you look at this life cycle where we have access, discover, launch, integrate, deliver. So we have different layers in the life cycle. Yeah. Now, so once we have all these layers, where exactly data quality comes in, and why we need to have data quality in this particular layer, not with other layers. Yeah. So let us start off having discussion on that. Yeah. Yeah. Now, the first and foremost thing, the data quality is what? Access layer. Not on data quality, in any warehousing tool, the first and foremost thing is what? We need to get the data from what we call source system. Remember, I repeat, first and foremost thing in data quality is going to be what? Get the data from what we call source systems, like OLTP systems in simple terms. So which means what? How do you get or how do you read the data from the source systems? That is going to be the key challenging part. To do that, first of all, we need to understand like what kind of data that we got from the source system. Is it going to be the structured data, or is it going to be unstructured data, or is it going to be application oriented data, or is it going to be legacy data? So that part we need to understand over here. So structured data and unstructured data and application oriented data and legacy data. These are the what I call 4 broader categories of what we have with respect to source system data. Once we have it, then next thing is what? We need to start understanding how are we going to read what we call this kind of data from that we get from sources. Let us pick up what I call structured data, where we can see data from flat file or data from relational table and data from what we call XML or data from, let us say, XLS and so on. This means what? Wherever there is a data which is represented in a homogeneous, consistent and formatted one, which we call structured data. For example, let us say we have 1, 2, 3 and 3, 4, 5 and 5, 6, 7. Assuming that we have this kind of data which is stored in a file, namely file.txt. In case if we have this kind of data, then how are we going to read the data from this particular flat file? That is going to be the what we call key challenging part. To do that, first we need to understand, is this a well structured data? Answer is yes in this case, because each field has been delimited with what we call comma. Let us say we need to define metadata, right? In order to read this data, C1, which is of type integer. And C2, which is of type integer, C3, which is of type integer, right? So once we define metadata like this, now we can start reading the data based on the metadata. How? Store output of this first field to this column 1, C1, and second field value, which is 2, third field value, which is C3. Yeah? Similarly, for the second row, same procedure will be repeated for each and every row. C3 is equal to 5. Likewise, what we call, we could able to read. So which means what, in case if we have the flat file data which is of the format of what we expect, then what we call this type of data is what we call structured data. Example. Yeah? Similarly, we can think of examples like data from relational tables, which means let us say you get data from relational tables like data from DB2, data from Oracle or MySQL, PostgreSQL or MS SQL Server or Teradata, NetEase or whatever. Which means what? They are all the databases which are in compliance with what I call RDBMS style, yeah? Which is Relational Database Management System style. Which means what? This is a specification which is RDBMS, right? So which means what? There is a predefined format available for RDBMS. So whatever the data that we get from any relational table, we consider such data as what I call structured data. Yeah? So whatever data that we get from relational tables, we call that as what I call structured data. So that's what we have over here, because in relational you will have n number of rows. Let us say n could be R1, R2, R3, n number of rows. Let's say 3 rows in this example, and corresponding columns, namely C1, C2, C3 and so on. Yeah? So which means what? In order to read data, let's say for this particular column, we can just file what is the query based on the table name and specify whichever column that you want and start retrieval of that particular what I call data. So which is what is the select, that's what we do, right? There is a fixed different format, select C1, comma C2, comma whatever, right? From this particular table, let's say T1. Yeah. So which means what? There are predefined formatted keywords which are defined through which what we call data has been represented in a structured form. So in this case, we can say that the data that we get from relational tables is also what we call structured data. Now, third example is going to be what? XML. Yeah? What if we get data from XML? Do we consider that as what we call structured data? Answer is yes, because XML itself is a language. Language should follow some what we call guidelines or syntax and semantics. Then only we can form what we call, we can form a language, right? Oh, you guys could not able to hear me, huh? Jaivir, Lalit, Naresh and Sridhar?
Unmuted.
Yeah, I can hear.
Oh, Lalit could able to hear. Jaivir?
Yeah, yeah.
Okay. How about Naresh?
I can hear you.
Sridhar, can you try to speak out now?
Mic is giving problems.
Yeah, we can hear you now.
Okay, Sridhar. You can hear me, right? Okay. I'll just mute because there is some background noise. If you have any questions, right, you can just put a question mark so that I can start asking questions. Yeah. Now, I was trying to talk about the structured data with one more example, which is what the XML. In XML, there is a concept of what we call XPath, which we call XML path, which means we can specify a path through which we can traverse to any subfolder or subdirectory and start reading the data from there. This means what? In XML, you will have what you call a data or the data which will be represented in the form of what I call tags, where you will have root and you will have what I call chain, and we can also have what we call grand chain and so on. We can have any number of levels. I'm just showing one simple example where we have 3 levels. Underneath you will have what we call key value pairs, where we can see key equal to A and corresponding value equal to some value. Yeah? And then close the tag for this, close the tag for this, and then close the tag for this, and then close the tag for this. So which means what, there is a fixed defined path, like a root, chain, grand chain. Within that we have key value pairs. In order to read the data from the deepermost chain, which we call grand chain here, what do we need to do? We need to traverse through from root to chain and then onto the grand chain, and within that we need to specify key, which is what is called A, so that you will get a value which is a 2222, which will be stored in some column. It's a C out column where you will have 2222. So which means what? For a given path and what is called key, you'll get a corresponding value here. Which means what? There is a predefined format again defined for this particular XML language, XML markup language. So that is why we consider this, the data that we get from XML also will be part of what? Structured data. Likewise, we can think of many examples where there is a need to consider such data as what I call structured data. So access layer is going to facilitate us on what is called reading the data which is of type structured. So that can be done by using what is called with the straight approaches like import, like we have import utilities, or we have different access tools through which we could able to read data from structured types. Yeah, there is a question from Naresh. Unless there is any, okay, there is, I think, the previous question. Will key work as a table name? Yeah. So it's a variable name, Javier. It's not a table name. Within a table you have column, right? So that column is equal to key, you can say. Javier? Okay. Now the next is what, so this is just a one column within this particular path. This complete path is equal to table in relational, and underlying keys, they are all equal to columns. And against column, you will have the value, right? This value is equal to what? For each row or whatever. So you can compare this with a relational table. But anyway, that's fine. Now the next is what we have other type of source data that you might get it, like data from SAP, data from PeopleSoft, and data from what you call CBEL, and data from what you call MRP, ERP, and so on, or even from Salesforce or whatever. So which means what, in case if you get data from these applications, how are we going to read it so that we can get it processed without any issues? To do that, we have to have what you call plugins or packs through which means what, for to get connected to SAP, we need to install either SAP pack or SAP plugin through which we can get connected to this SAP. Underneath, you will have corresponding database from where we can pull the data by using what? Again, access layer. So access layer will be used in order to read data from what you call different types of sources, where you will have structured, unstructured, application oriented, legacy, and so on. All of them will be taken care of by using what? Access layer. Yeah? For example, for application oriented data in Informatica context, we use either Power Exchange or straightforward plugins. In both the ways, we could able to read data from what we call all these external applications. Yeah? Now, the third is what? Legacy, which means what? In case if you get data from mainframes, then how are we going to take care of reading the data from what we call mainframes? Yeah? So that will also be taken care of by using or by having mainframe plugin, through which we can get connected to that and start reading the data. Yeah? And then we have what we call unstructured, which means what? In case if we have or if you get the data from email or data from PDF documents and data from Word documents and so on. In case if you get data from what we call these types, which we call them as unstructured type, how are we going to read the data from them? Yeah? So to do that, we are going to take help from what we call B2B data exchange, through which we could able to convert unstructured data to structured. From then on, reading the structured data is a straightforward. Yeah? So B2B is one of the what we call important tool in Informatica product suite, which is going to facilitate us on what we call taking care of this unstructured part. Not only that, it has got many. I'll not get into that. It's not the scope of this training. Yeah? So that's what we do here. But this is very complex, because if you take a PDF document where you will have simple text, yeah, and you will also have complex text, or let's say paragraph, yeah, and paragraph, yeah, and you will have what you call icons, or embedded icons, and embedded images, and then we'll also have what you call tables, and so on. So we can have a mix of several things within a document, right? In case if we have that, data is not in one format, right? So which means what? We need to identify a way to convert this different mix of different types of data within one single PDF document to a structure, which requires a lot of understanding with respect to keywords that we have in simple text and paragraph, and then convert them to columns and then start reading the data from text part. And icons, we need to identify how to read it. Similarly, images and tables. Yeah. So this is a complex part. It's not that straight. Yeah. So that part will be taken care by using what we call many unstructured data readers. One of them is what? B2B data exchange. Yeah. Which means what? Access layer is going to help us on getting the data from any of these sources which we discussed. Fine. Now we know how to read data from sources. Once we are done with that, what do we do as part of next step? That is going to be the challenging part. That you will see as part of what we call next layer, which we call discover layer, where we are going to use discover layer in order to carry out analysis, or in order to identify positive or negative points with respect to source data, or we can use this just to profile the data. That's it. Which means identify the strengths and weaknesses of the source system data. To do that, in data quality, we have what we call a separate tool like Data Explorer or Informatica Analyst, which is going to help us on carrying out this particular discover part, which means analysis part. Yeah? So where, let us say some examples how many duplicates we have, how much is the null data we have, do you have any metadata issue, do you have any range data issue, do you have any pattern issue, do you have any what you call range, which is out of boundary data issues, which means what? Such issues will be identified as part of what we call discover layer, which is going to be the complex part, which is not that straight. Yeah? That is why, especially if you want to analyze, you need to have deeper expertise on data and also the business. That is why business analysts or subject matter experts or data analysts, they are the right people who can carry out this particular analysis. Even developers also can do that, provided they need to have deeper expertise on those activities which I was trying to talk, which will not be the case for most of the developers. I would say more than 95% of the developers, they would not have it because their scope is different, right? So that is why the right people or right stakeholders of this particular discover layer is going to be what? Subject matter experts, data analysts or business analysts. They are the right people, and they can make use of Explorer tool or Informatica analyst tool, which is part of data quality, in order to what we call profile the data. That is where this discover layer is going to help us. Yeah? In Informatica, what is the product suite, we have a tool called Informatica Analyst, which is going to be the web-based client, which is going to help us on achieving this particular analysis. Yeah? Now, the next is what? Assuming that you identified or you understood like what kind of data that we got from the source. Next thing is what? We need to start identifying, do we have any quality issues with respect to profile data, which means what? We cannot do complete what we call data quality parts over here. Only partially only we can identify, like a duplicate this many, unique or nulls this many records, and so on. We can only identify or understand the data, but in case if you want to perform like a parsing, standardization, enrichment, matching and merging or consolidation, and come up with a what we call final formation of a record, which we call a golden record, which I was trying to talk here, right? This one. Yeah? To get there, what we call, we need to use what? This particular layer, which we call plans layer or quality layer, which is going to help us on what we call formation of final record, which we call golden record. Remember, yeah? We'll talk about that. To do that, we have IDQ client or Informatica developer client. Within this IDQ, through which we can start formation of a final record, which is going to be the master record. Yeah? After that, we have watch. Once you create a final record, right? This record will be taken as input to any ETL tool or any other tool, where they can start making use of this good data and apply their own business rules. That is where we have another layer, which we call integration layer, which means what? Output of data quality will become as input to the integration layer, which is going to Power Center or whatever, and start applying business logic for good data rather than applying the business logic for duplicate records, which we have seen as input to data quality, right? Yes or no? If you apply, normally what is happening is in the current market, people are applying what you call business logic for each and every row, though it's not required. Yeah? So that problem also will be solved by using this, which is what? Use quality and create a good data, apply business rule for the good data rather than what you call apply business rule for or business logic for bad data and good data. It's a mix of both, right? We are applying unnecessarily for the data which is not required to be applied. So that will be eliminated. So as a result of that, we can deliver this data to a final target, which is a warehouse. So warehouse, you will have what you call very good data that can be taken as a base in order to take the business decisions. Yeah? So which means what? If you use right data, then you can take right decision. If you use wrong data, then there is a chance to take wrong decisions. So which means what? So customers, they would expect right data, right? So we need to deliver right data. How do you do that? By using what you call data quality. So as part of this data quality training, we are going to cover discover layer and what you call cleanse or quality layer. These are the two layers which will be covered as part of this training. Yeah? That's what will happen. So which means what? You need to have data, or you need to qualify the data. After that, we can get into Informatica Power Center, which is an ETL tool, which will be used in order to what I call perform data integration. Fine. So this is the simple what you call way to explain the complete life cycle of what we have in Informatica product suite. Any questions here?
Unmuted.
Hi, Mr.
Yes, Lalit.
And give me just 1 second, I'll be back.
What, Lalit? Can you please repeat?
No, it's not me.
Javira?
Yeah, Javid, just give me 1 second, I'll be back. Just 1 second, please.
Okay. Okay. Yeah, probably can just ask later if you have questions, David. Yeah. Now, the next is what we have. Where do we use this all these layers? Yeah. To answer that, we have top areas, right? So we use these layers for building the final target, which we call data warehouse. Yeah. So data warehouse, we all know that, right? Collection of data from multiple sources. Yeah, this is what you can see, 3 sources collected. In between you can have logic. I'm just not talking about that. Then data migration. So we can also use this one or more of these tools on each of these layers, right? So those tools can be used to perform migration. Example, Power Center. We can migrate from legacy, which is from mainframe to what we call Teradata. Example. So that is what we call data migration. Yeah. Then we also have what we call data consolidation. What do we do as part of this? We are going to what we call convert n number of what we call matching records where there are duplicates, right, into one single record, like what we discussed as part of this particular example. So there we are going to use data quality. So data consolidation is meant for that. Yeah? And master data management, it has been designed for domain specific like customer, product and so on, wherein we can create what we call again golden copy based on kind of domain that we are going to deal with, like a customer domain, customer golden copy, product domain, golden copy and so on. Yeah? And synchronization, in case if you want to validate or if you want to perform any synchronization, such things will be taken care by using synchronization. But for this we have a separate tool which we call data sync, through which we can achieve this synchronization. Plus finally we have B2B data exchange. In case if you want to deliver data to a target which is unstructured form, then we can take help from B2B exchange, or if you want to read data from that is unstructured, we can also take help from B2B data exchange, yeah, which is going to help us on unstructured and also what WAF data or whatever. Yeah. Now that's about areas. In simple terms, if you think from the quality perspective, these two what we call layers will be used in order to do this operation, which we call data consolidation, which means we are going to identify matching records, consolidate them to a single record, yeah, which is what will be done as a result of what I call data quality, which is the key part over here. Clear? Data sync. No, Power Exchange CDC is different. That's just change data capture. Yeah. Power Exchange CDC for DB2, CDC with Oracle, CDC with what I call Teradata SQL Server, right? That has been designed to capture change, yeah, for different databases. That is different. Yeah. So data sync is different. Synchronization basically to take care of synchronization issues, not CDC issues. Naresh? Okay. Now the next is what we have. In the bottom, you can see what there are three separate interfaces. One is what we call audit. Audit interface will be used, or audit tool will be used in order to keep track of changes with respect to the metadata and also with respect to the data. I repeat, audit trail or audit framework will be used in order to take care of what I call keeping track of changes with respect to metadata and also with respect to data. Yeah, we can do that. There's a question from Sridhar. Can we use data quality tools before usage of this, before using the MDM? Yes. For example, we can use data quality tool to perform standardization, cleansing and enrichment and take that as an input to what I call MDM. Sridhar? So, which means what? Simple address standardization. We do it in IDQ and integrate with MDM. In MDM, use this address standardization input in the form what is a cleanse function in MDM, right? So that's an example like how we can perform standardization data quality and use it in MDM hub. See that? Yes, that is the best way because MDM is not that great to perform what I call this data quality part, especially standardization and cleansing as well as what I call name standardization, telephone standardization, zip code standardization, right? All that we don't have it. For that anyway, we need to take help from third-party quality tools. So take care of that in quality tools and then integrate that with MDM hub. That is the best way. See that? But if you could able to do in MDM hub like whatever is required for the business, then no need to think on this third-party tools. Yeah? But mostly not in real projects. Yeah? So that is why it is always advisable to have a combination of IDQ and MDM, which is the best combination. But there are some customers who are using only IDQ or some are using only MDM. It depends on kind of requirement that we are going to give. But majority of the customers, they would use both IDQ and MDM. Yeah? Fine. So that's about what I call auditing part. So just to keep track of changes of data and also metadata. Yes, Javier, go ahead.
And the using of IDQ or MDM depends on what type of data we have. Is it?
Javier, I can't hear Javier. Can you speak a bit louder?
And the using of IDQ or MDM, that will depend on the kind of data we have.
Yes. Yeah, kind of data that we have, that's one thing. And kind of functionality that is being expected by the business. These two things are going to play a key role. Javier?
That will decide like what type of the data quality tools or the ETL tools we will require.
Exactly. Quality, ETL and MDM, 3. Yeah.
That's good, yeah. Thanks.
Fine. So then once you audit it, then the next thing is what? Monitor. Let's say you want to monitor the data based on what since last 1 month. Yeah. So we need to know like what I call since last month, like what kind of quality data that we have. To answer that, monitoring framework or monitoring tool is going to help us where we can monitor the data quality progress over time. Yeah? So that is where this monitor is going to help us. No? There is a question from Naresh. When DQ can merge and create master data, why do you need MDM specific? As I was saying earlier, see MDM is it is a superset of IDQ, remember, data quality, because MDM is what it has got wide or exhaustive features than compared to data quality. Example, integration of different quality tools, integration of third-party authentication authorization, integration of what you call third-party workflow engines. All that cannot do it in IDQ. IDQ is a very small piece where we can take care of creation of good data for given input data. But there we have many more capabilities like data steward data management. We have separate data steward tools. We also have hierarchy management, which can't be done in data quality. So which means that we have many things in MDM which we don't have it in data quality. That's why we need to suggest customer to to choose MDM in some cases and data quality in some cases, depending upon the kind of requirement that they need to deal with. Yeah. And monitoring part, we use it to measure the data quality progress over time. Reporting part, in case if you want to integrate this data quality with the third party reporting, we could do that. Start generation of what we call reports. Yeah? So this is data quality reports. So that's about what we call simple explanation about this particular diagram. Yeah? So once we understand this, then we can get into what we call data quality architecture, where we can talk about like what are the different layers of what we have in the data quality and start what we call making use of those layers in order to achieve data quality objectives. Yeah? So that part we need to talk. Can you see here? This is the version that we are going to use in this particular training program is going to be what? 9.1 and also 9.5.1. So we have both the versions. I'll talk about 9.1 just to start with. Once you finish that, I'll just talk about what we call additional features of what we have in 9.5.1. So which covers both the versions. Yeah? So we have what we call in this architecture, we have 4 layers. One is what we call client, second is what server, third is what meta, which is a repository, and fourth is what content, which we call a reference data layer or content layer. These are the what we call 4 layers of what we have in this particular Informatica data quality. Yeah, I think we'll stop here because too much theory is not a good thing. I'll make this what I call